about 4. What do you do first? You group the like terms. Group the like terms. So at this point, look at this. What we did here is we first of all group the like terms. Then the next step is you collect the like terms. Right? So let's group the like terms first. For the first one, we have 7a power 4 plus, that should be negative 2a power 4 plus 5a.
You had another negative a to the 4.
We have another negative a power 4. Thank you. At the end, minus a power 4. That's all right. That's all for this a power 4.
5a
Plus 5a
minus 4a.
minus 4a. Is that all? That's all right. So, okay. 7a power 4 subtract 2a power 4. Subtract a power 4. What do you get?
4a.
You said?
4a.
4a power 4, yeah. 4a power 4. What about this? A. As simple as that. So, I believe that by now we all understand what mathematical expression is. Variable, coefficient, basic operation of addition, subtraction of mathematical expression. So, you know what we do basically in mathematics most times is like a change of variable. So, you can do like a twist. You can be given like a twist like assigning this polynomial or the values of that expression to a different value. Look at what I mean. So, you could be given something like, what do you say? Okay. Could be given something like this. I still want to leave this so that you'll be looking at that illustration there. So, you could be given this. Given that Z1 is equal to t squared minus 8t minus 7, and Z2 is equal to t squared plus 5t minus 6. Now you are asked to do what? Find Z1 minus Z2. So you could be given something like this. You can see that everything, all this mathematical expression, everything here is assigned to Z1, while everything here is assigned to Z2. I ask you to subtract. So, solution. Z1 is what? Z1 is t squared minus 8t minus 7. This is the Z1 minus Z2 plus 5t minus 6. So what to do at this point is you use this subtraction sign, because naturally this means -1. So you use -1 to open up this parenthesis, right? So you use -1 to multiply each of these terms. This first term here, the second term, and the third term. Is that clear? But if it's an addition, you just need to just do your normal basic operation. But because of this, you have to recognize that -1 will be multiplying everything inside this parenthesis, all the terms. First term, second term, and third term. Is that correct? So here we have what? T squared minus 8t minus 7 minus t squared minus 5t. Minus times minus will give you plus, right? So whenever you multiply minus with minus, it will give you plus. But if you multiply minus with plus, it will give you minus. Right? So minus times minus will give you plus. Here we have plus 6. What do you do next? You group the like terms. If you group the like terms, you have what? T squared minus t squared minus 8t minus 5t plus 6 minus 7. Right? T squared will cancel t squared. Is that correct? T squared minus t squared will give you 0. Right? So it will cancel out. Minus 8t minus 5 to give you minus 13t. Right? Minus 13t. 6 minus 7 will give you what? Minus 1. So this is your final answer. So I want to give you a problem that is similar to this. Right? Okay, so given that Z1 is equal to M power 3 minus 5 N plus N power 2 and Z2 is equal to what? Two M power 2. Or let's say 3 M power 2. Minus N squared plus N. Find first 1 Z1 plus Z2. 2. Find Z1 minus Z2. 3. Find Z2 minus Z1. You are done?
Well, no, you have Z1 equals and then Z1 equals.
She forgot to
You
label
don't have a
Z2.
Z2.
Yeah.
Okay, this should be Z2. I don't know what's wrong with that. Maybe old age. What you do, just pick one of these and solve it in 2 minutes. I want us to do it individually. Then just pick one of them, either Z1 plus Z2, Z1 minus Z2, Z2 plus minus Z1. Just 2 minutes. If you are not done in 2 minutes, that's okay. We'll still find a solution together. Is that correct? Yeah. Good. I can see the amazing work you guys are doing. 1 minute more, then we'll find a solution. All together. Okay, are you done with at least one of these? Are you done with at least one? How many of you are done with at least one? Oh, everybody. That was very wonderful. Okay, so let's find the solution all together. First of all, what did you get? The first one. Who solved the first one? Z1 plus Z2. Okay, you.
I got 4n cubed minus 4n.
Okay. Did any person get the same answer? Okay, correct. What about the second one? Okay.
I got negative 2n cubed minus 6n plus 2n squared.
Is that correct? Someone got a different answer. Someone got a different answer.
I got the same one.
You got the same answer? What? You got a different answer?
No, I'm wrong.
Okay. Okay. So what about the third one? Z2 minus Z1. Okay, Zach. Hope I pronounce your name correctly.
Yeah, that's good. I got 2n cubed minus 2n squared plus 6n.
Very long. Who got the same thing? It seems like you solved all three.
I did.
Oh wow, that's wonderful. Super fun. Okay, let's find the solution together. So solution. So from the first one, which is Z1 plus Z2 is equal to, we have Z cubed m cubed minus 5n plus 2n squared plus 3m cubed minus n squared plus n. Hope this is correct. This is equal to, you group the like terms. Let's group the like terms together. M cubed plus 3m cubed minus 5n plus n plus n squared minus n squared. From this, you collect the like terms. You now collect all the like terms together. M squared, m cubed plus m cubed plus 3m cubed will give you 4n cubed. Minus, you have minus 4, right? Minus 4n. This will give you 0. So this is what you got, right? Then, number 2 is Z1 minus Z2. This is equal to what? M cubed minus 5n plus m squared minus 3m cubed minus n squared plus n. So you use this negative 1 to distribute into the parentheses, right? If you do that, you have m power 3 minus 5n plus n squared minus 3m cubed plus n squared minus n. You group the like terms. If you group the like terms, you have m power 3 minus 3 m power 3 minus 5n minus n plus n squared plus n squared. So this is equal to, here we have negative 2m cubed minus 6n plus 2n squared. Is that correct? Good. That's what we got, right? So what about the third one? Where should we solve the third one? Let's solve the third one here, which is z2 minus z1. So this is equal to 3m cubed minus m squared plus n minus m cubed minus 5n plus n squared equal to, you do the same thing, use this negative one to distribute, and you have 3m cubed minus n squared plus n minus m cubed plus n minus n. So at this point, you group the like terms. Hence you have So after grouping the like terms, what do? You collect the like terms. As here we have 2m cubed minus 2. Hope this is correct. This is what we all got. Right? Good. So now, before we talk about mathematical equation, we need to understand some properties of number. So we have these properties of number that we need to take note of. So the first property is commutative property of addition and subtraction. Right? Let me clean up here. So the first one is commutative property of addition and subtraction, which says that if you have A plus B, it is equal to B plus A, saying that the order does not matter. When you say that something commutes together, meaning that whether you rearrange the order, it doesn't matter. And this commutative property of number was for addition and multiplication. Right? Yeah. So the first property, the commutative property, the first property is say that if you have commutative property, if you have A plus B is the same thing as B plus A, and this also works for multiplication. Right? Meaning that if you have 2 plus 3, it is the same thing as 3 plus 2. Now look at my finger. If this is a group, you have 3 plus 2. What do you have in total? 1, 2, 3, 4, 5, right? If I decide to change this, change the order, now I have 5, I have 3 here, I have 2. What do I still have? I still have 5. You can also see it in multiplication also, because if you say 2 times 3, 2 times 3 means 2 groups of 3, right? So if you have the first group, you have the second group, you have 3 things inside. You have 3 things inside, right? So we have a total of what? 1, 2, 3, 4, 5, 6. Right? If you also have 3 groups of 2, you have 3 groups, you have 2 things inside. You have 2 things inside in each of them. What do we have in total? 1, 2, 3, 4, 5, 6. This was for addition, subtraction. But this is not true for subtraction. It is not true for subtraction and division. Is that correct? So the second one is, and this can also work for more than 2 variables. Right? It can work for more than 2 variables in the sense that if you have a plus b plus c is equal to c plus b plus a. And also maybe for a times b times c. This is a, c times b times a. It works, but not for subtraction and division. So the second property is associative property, which says that if you have a associative property, we say that if you have a plus b plus c, if you have parentheses here, the parentheses doesn't matter. What do you call? Okay. A plus b plus c. So even if you have this parenthesis here, doesn't matter. And this also works for addition, for multiplication, I mean. Right? So hence if you have 2 plus 1 plus 2 plus 3, it will still give you the same thing, the same answer with. Whenever you rearrange, in fact, the order of parentheses doesn't matter. Hope you got what I mean. So the third one is distributive property. Distributive property. This one is saying that if you have A and you have parentheses, this is similar to what we did in what we just did here when we use the subtraction sign, negative one to open up the parentheses. Here if you have B plus C, this says this is equal to A times the first term and A times the second term. You have A, B plus A, C. So if you have any number here and you want to open up this parenthesis, you have to use the number to distribute into the first and the second term. Right? Now, mathematical equation is mathematical equation shows that 2 mathematical expressions are equal. The idea of mathematical equation is the idea of balance. Because I've noticed this kind of misconception about equal sign. People see equal sign as an output, while it is not. So I want you to understand this conceptually. So at this point, it might not matter, but when you go ahead to solve some, when you get to the level of solving higher mathematics, the way you think about maths determines so much, determines a lot, right? Because I was solving something that has to do with an equation one day for my student, and I ended with maybe 5 is equal to x. And they said no, that I'm wrong. The x should be this side, and it should be x equal to 5. Could you imagine? I said, but it's the same thing. They said no, it should be it should be here. That means we are reasoning x as an output. It's just like when students learn some conceptual understanding, they don't have the conceptual understanding of place value. Right? When they don't understand, they don't have this conceptual understanding of place value. And the answer might be misleading at that initial stage for kids. Do you understand? When you have all those place value, this of multi-digits, 2 times 12, this will be very easy. So they might be solving, they might be multiplying from right to left, and it will not show. right? But once you go ahead to solve some higher problems like multi-digits, maybe 57 and what do you call it? Maybe 12. It will definitely show, because once you start coming from right to left, it will show, because they need to understand that place value, that when you multiply this to this, you give you 14. You have to write 4 and carry 1 and place it. So if they don't understand the concept of place value using the box or modeling it using base 10 blocks, at this level, they will be getting all the answers correct. And as a teacher, you will be thinking that they all got it correctly. So that's why I always emphasize on the way you understand this. Now, equal sign should be seen as a balance, where what we have in the left-hand side is the same thing as what we have in the right-hand side. Right? So that's the simple concept of equation. Right? So all this mathematical expression that we have, maybe call that first mathematical expression that I gave as an example, the very first.
2x plus 5y plus 8.
Plus what?
8.
8. So if all this is equal to 0, this is a mathematical equation. So without 0, everything is mathematical expression. But having 0 here equal to 0 means it's a mathematical expression. Right? So what I'm saying, I don't want you to start seeing this 0 as an output. But understand that this actually means that if you find the value of this variable x and variable y, and substitute this value, you are getting the same thing as what we have here. Because sometimes, you don't have 0 here. You have a different thing. Right? So whether anything you have, what if you have maybe x plus 3, maybe x plus 3 equal to 5. This means that if you substitute or find the value of x and substitute the value of x here, you will get 5. Right? What do you think the value of x will be?
2.
The value of x will be 2. So that means if you substitute the value of x here, you have what? As 2. You have 2 plus 3. You have 5 equal to 5. Right? Okay. So from this, let's look at change of subject. Let's look at change of subject. I want us to solve some examples. I want to illustrate more before we do some demonstration of this mathematical balance from our topic outline. So change of subject simply means assigning a new value, a new variable as the subject. Meaning if you have this, maybe x equal to m n plus y. This x is the subject here. If I want to make a different variable subject, I'll just have to do some basic operation. I have to do something to make a different variable subject. That's simply the concept of change of subject. I think I have a definition here which I can give. Where is that definition? Okay, so change of subject means either rearranging an algebraic formula to isolate a new variable or changing a topic in conversation. Means that the subject, the variable in conversation will not be x again. I want to change it to n, so that n will be standing on its own, just like x, or y will be standing on its own. Right? Okay, so but there are basic ways of solving this changing the subject. I need to understand some basic rules of changing the subject. I need to clean the board. enough. So change of subject. Now, we have to solve the first type, type 1, which is equations without fractions. Type 1. Equations without fractions. Right? So when you are asked for to do what? Make x the subject of the following. Make x the subject of the following. So here you have 1, you have v u plus ax. 2, we have 7x plus u equal to vu. 3, we have y equal to d e f plus x. 4, you have y equal to x minus a b c. Okay, let's start from this. So, whenever you have an equation that without fraction, this doesn't have a fraction. What you do is, I ask to make any subjects here. The first thing you do is, you make sure that everything as a whole, both equation, everything should be standing on its own first. So one solution. Here you have v. You take this one, bring it to this side. And when the sign of addition crosses the sign of equality, changes to minus ax. Now look at the idea. The idea is that I want to make x a subject, but x is having a at the front. What I want to do, I want to eliminate what we have here. I want to take out u, so that I will not have u at this side. Right? So it's more like I have a bigger problem, but I want to solve, I want to just eliminate something. Like I just want to do something to cut out the weight of my problem. I have everything here. I said, if I'm able to eliminate this u, I'll have a lesser problem. I'll know that I only have to deal with a. Is that correct? Now the idea of what I did here is, when the sign of addition crosses the sign of equality, changes to subtraction. The idea is, if I want to eliminate u, what do I do naturally? If I have u, I have this. Let me write out this equation again. Ax. This is my equation, right? See, if I have u here and I subtract u, that means u will be out, right? But because this is an equation, I want anything I will do in this right hand side of the equation, I have to do it in the left hand side of the equation, naturally. That's how I have to subtract u also. Right? Naturally, you have to do this. Whatever you do in this left hand side, also have to repeat it in the right hand side to have like a balanced equation. Right? So if you do that, you have this. You have v minus u. U minus u is 0, hence you have ax. That's how we arrive at this point. You can think it from this angle. I think this is more explicit. This is more understandable than having the mindset of when the sign of equality crosses the sign of equality. Yeah. So From this, what do? You divide both sides with the coefficient of x. Look at the mindset. A is here. What do I do? If I want to eliminate A, just like I saw u plus u. To eliminate u, I have to add minus u. And the u was out, right? If I have A in front of x, if I want to eliminate x, I have to just divide with A. Let me just divide with A. If I divide with A, it will go out, right? A divided by A will give you 1, right? But if I do this here, I have to also do it here. Is that correct? Hence, you have v minus u over A equal to x. Now, x is the subject of this equation. It's very natural. Just have this mindset that when you're making a subject, whatever you do here, you do it. I think this is even better that you learn it through this mindset than using the language of cross multiply, do this, do that. Right? I think at this level, for me, and that's what I normally do, I just like very fast. But at this level, you need to understand it through this way that whatever you are doing here, think of something that you do to eliminate what you are having close to. Whatever is an obstacle to making that x subject, what will you do to eliminate that? Once you factor it out, that you're able to do this, to eliminate this in that side of the equation, whether it's this side or this side, make sure that you are applying the same method to the other side. Is that clear? Good. What about the second one? So the second one is you have 7x plus u equal to vu. I have a bigger problem. Let me eliminate u first. If I eliminate u minus u, it will go, right? I have to do the same thing here. Minus u. This will cancel this. I will have 7x equal to vu minus u. What do I do to eliminate 7?
Divide.
What do I do?
Divide by 7.
I have to divide by 7. Let's divide by 7. Good. Since I divide by 7, what do I do next? I have to do the same thing here. Correct. I have to do the same thing here. Hence, we have that x is equal to uv minus u over 7. As simple as that. You can see that mathematics is very straightforward. Right? Okay. Let me solve number 3. Then maybe we solve 4. Okay, so number 3. Solution. You have y equal to def plus x. What do? I have to subtract. I have to eliminate this first. I have to eliminate def. And if I do that here, I have to do the same thing here. Minus def. Right? def will cancel def. Hence you have y minus def is equal to x. Why the next one will be 4. Y equal to x minus ab. This will come here. It will be y minus plus abc equal to x. Now let's solve more example. I will give you example 5, 6, 7, 8, maybe 4 more. Then you pick just two of them and make S the subject. Is that correct? So now I want us to do it in pairs. I want us to interact while doing it. Right? I want it to sink in. Let's just take like 2 minutes. You do it in 2 minutes. So if you are not done in 2 minutes, that's okay. You'll still find a solution. Right? So you have number 5. You have y equal to minus b plus x 6. R y plus 2x equal to t x plus 4. 7. 3x minus a x equal to 2x plus 5.
Question.
4x plus c equal to w. 4x plus c equal to w. 8. 4x plus c equal to w. And what? Maybe dx minus t, what's 8? Dx plus, okay, minus t. Minus t equal to 8. From this, just pick 2 and next as the subject from all this.
What's the first thing on 6? Is that 2y?
6? No, this is ry.
R.
This is r, yeah.
Okay.
One thing you have to take note of before you do your solving, just have to take note that you can make any variable the subject. Right? It could be any variable the subject and not necessarily x. Right? You know, people always have this misconception that you only have to find x, it has to be x and y. This is just like a representation of a variable. So it could be m, a. That's why I don't like using only x and y. I like using so many variables. So you can say r. Right? But for now, make x the subject. Just pick 2, make x the subject. Just you can do it in pairs, group of 3 or so. You have 2 minutes. If you are not done in 2 minutes, that's okay.
That's what we got to.
Okay, Sarah. That's okay, do it. Make it so. Should I use a different way? I don't know. To avoid touching it, let me make use of a different. Yes. Yeah. Thanks for letting me know about it, man. You are free to interact within yourselves.
Oh yeah, right. So long. First, did you do it? I did it.
many of you have done with at least one? Almost everybody. Yes. More 30 seconds. Okay, so for the first one, what did you get? X is equal to what?
Y plus B.
Y plus B. Correct. What about number 6?
I got x equals ry minus 4.
X equal to ry minus 4. Who got the same thing? Did any of you get the same thing? It's not looking like it. Did any of you get the same thing?